All right, this is my second recording of this video. I got one wrong. Okay. Okay, so if I get one wrong this time, I just, we're gonna, it's the same thing that I expect you to do if you get it wrong. You're gonna look through the solution, find your mistake, and that would be a yellow problem if you can find your mistake, and a red problem if you can't. But it doesn't mean, you can't do it. And okay, so, and of course, okay, so we're gonna do IXL. You're gonna do each assignment for 10 minutes for completion, since we're switching from Khan Academy this week at least. And so there they are. IXL has a lot of good resources, so I just want to show you that really quickly. And I'm really gonna try not to make a 30-minute video. So if I keep talking a long time, just stop me. Okay, so here is our 8th grade math. And one thing that I really like about IXL is it goes back. So like, look, coordinate plane review. That's not 8th grade, but it is needed, to do the other things. So your prior knowledge skills, they're here too. And then if you scroll all the way down, you have all these study guides. So like, we're gonna do two-way tables right now. And there's a study guide for two-way tables. Okay, so you can read through that. There is more information in the study guides than what we'll cover. So if you are reading through them to try to help you, and you get to something like lines of best fit talks about least squares regression. So we are not going to do that in our class. Get something that we haven't talked about, just ask about it. Make sure it's not something we missed, or maybe something you missed. Okay, so let's start out with the two-way tables, which is brand new. A store recently released a new line of alarm clocks that emit a smell to wake you up in the morning. Interesting. The head of sales used ages to track ages and what tracked users' ages and which smell they preferred. Okay, and what is the probability that a randomly selected user chose a clock scented like cinnamon and is under 13 years old? So we have two columns. One is the column that are under 13 years old, and one is a teenager. Goodness. Okay. And then our two rows are the people that chose bacon and the people that chose cinnamon. Okay. And so what we want is our total. We want to add two little sections. We want to add the totals for below and then the totals to the side. So we're going to add them together. 8 plus 3 is 11. There's 11 people total in the study that chose the bacon scent. 8 were 13 or under 13. 3 were teenagers. 2 plus 7 is 9. So there's 9 people that liked cinnamon. 2 were under 13. 7 were teenagers. Adding vertically, we have 10 people that were, goodness, man. Unplug this. Plug it in. So there were 10 people that were under 13. And then there were also 10 people that were teenagers. Okay. What is the probability that a randomly selected user chose a clock scented like cinnamon and is under 13? That's 2. Oh, and we need our grand total here. So 10 plus 10 is 20. Also 11 plus 9 is 20. This is our grand total. How many people in the study? And so 2 people fit that description out of the 20, which is 2 over 20. But if I put 2 over 20, that's not reduced. I can divide both of those by 2. giving me 1/10. And that was right, guys. All right, let's do one more. A sociology teacher asked the student, okay, blah, blah, blah. What is the probability that a randomly selected student is irresponsible and has 0 siblings? Okay, let's add 12, 6, add across, we get 8, 10, get our grand total, which is 18. So, and they're irresponsible with 0 siblings, so that would be 5. So it should be 5 out of 18. Okay, so just the Edpuzzle alone, and you're gonna get at least a smart score of 26. Might have to try a little bit harder to get up to 80. Don't forget about your red problems. Okay, so that was the two-way tables. Find that grand total, and then write your fraction. Don't forget to simplify. How's about let's do the checkpoint for irrational numbers and rational numbers. Okay, so determine whether each number is rational or irrational. So a little bit of a review about that. Rational numbers. What is a rational number? It is an integer over an integer. Okay, so it could be simplified like 2 is a rational number because we could write 2 over 1 as an integer over an integer. 3/7 or -3/7, -7/3, whatever. These are all rational numbers. 0.3 repeating is a rational number because it can be 1/3. So any number that can be expressed as a fraction is a rational number. And you would think, can't you write every number as a fraction? But no, there are very special numbers like pi, which is 3.141592, and it goes on forever, and it never has a pattern, right? No pattern, no end, and yeah, and it can't be a fraction. You cannot write these guys as a fraction. You have to use special symbols or approximations. And so examples of that are, like I said, pi. There's another one, E. There's another one, the golden ratio, which is, but it's another one. And then anything that is a square root, that's not a perfect square. These two are gonna be the ones that they try to make sure you can identify. So like the square root of 50, that is not a perfect square. We should know that our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. You should at least know the first 15 perfect squares, right off the top of your head. And 50 is not in the list, so it's irrational. This is rational, irrational because it has a pi. And although that has a square root, 9 is in the list. That's just the square root of 9 is 3. So this is just 3 over 3, which is 1, which is rational. So let's just check that off and do one more without notes. Keep it up. Okay, let's keep it up. Which of the fractions are equivalent to 0.27 repeating? Okay, so this was the first lesson of the year for me when I was teaching 87. Don't know what you guys did in the other classes, but 2 repeating digits is going to simplify to is gonna be 27 over 99. So when you have two digits repeating, your denominator is 99. If you had one digit repeating, your denominator would be 9. So like 0.4 repeating is 4/9. And if you had three digits repeating, 373, like that would be 9/3/9. So that's the shortcut. We actually did equations to solve it. We can do that later. So I'm going to do 27 over 99, but then I have to make sure that I reduce my fractions. I'm going to get this wrong. So let's see. 27 over 99. But then I know that 27 is 3 times 3 times 3. And 99 is 9 times 11. So 27 is 3 times 3 times 3. 9 is 3 times 3 times 11. So now I can cancel out some things. And so 27 over 99 is 3/11. Woo! Not easy. Oh, okay. So like I said, I am not gonna record this just because I missed 9 over 33. But if you see, I went right down to the simplest one. But if I would have only canceled 1 3, then I would have gotten 3 times 3 over 3 times 11. If I didn't cancel out both threes, and that would have been 9 over 33, which is the one that I missed. Dang, my smart score went down. I hate this. All right. No, I'm just kidding. But I know that's what most kids feel. Which kinds of numbers are irrational? Okay. Decimals that do not terminate or repeat. Makes and everything else is rational. Okay. Rational, irrational. Okay, this has a non-perfect square. This is fine. This has a non-perfect square. This is fine. Want to do one more? You got it. You got it? Okay. I better keep moving on so I don't make too long of an Ed Pulse video. Okay, so we got two systems of equations, lines of best fit, and oh, you guys lucked out. Look at that. I put the same one twice, right? Let's make sure that that's not a typo. So if you see in this document, I have put the Excel assignments there. And you can see what we're doing here. So we got rational versus irrational, lines of best fit, interpreting slope and y-intercept of linear models. Did I put that one there? Oh no, okay, I'm gonna have to change this. So, okay. Interpreting slope and y-intercept of linear models. Let's do it. I'm gonna do one of each. Kiera enjoys working on jigsaw puzzles with her grandfather. This scatter plot shows the number of pieces in some puzzles they have completed and the amount of time it took to finish each puzzle. It also shows the line of best fit. Wow, that's awesome. The equation for the line of best fit is right there. Okay, so what am I thinking right now? I'm thinking that this is the slope, a very small slope, and this is the y-intercept, the initial amount. Okay, so I don't know if we've talked about this yet, but even if we have, it's a great time to review. Slope We have some slope words like per, each, for every, for each. When you see these things, they're asking you about the slope. Y-intercept words are different words. They might say initial, starting, beginning. They might be talking about a fixed amount. I believe on the quiz we saw a service fee, right? And then we know they're asking about the y-intercept. So when I saw a puzzle would likely take about this many hours to complete, so I'm gonna need the slope for that. Okay, it's not talking about the beginning amount. It's talking about a rate. That's what I'm thinking. That's what I'm thinking. So let's look. A puzzle with 1,100 pieces would likely take about 10 hours to complete. Okay, so I'm also looking at the axes. So we have number of pieces are the X value and completion time is the Y value. So let's substitute it in and see if it works. So I'm going to substitute my X value into this equation and see if it equals the Y value. So I have my equation 0.012x plus 0.1. And if I substitute what does that equal? Does that equal 10? We're about to see if that equals 10. So 1100 times 0.012. And I get 13.2 plus 0.1, which is 13.3, if my calculations are correct. So I'm going to say that's not 10. So I'm not very confident in that one unless I made an arithmetic error. But how about this one? X, Y. So is 1,000 pieces. I like my chances for this one because I'm looking at 12 there. And if I multiply that by 1,000, that is gonna be, it's gonna be 12. And then if I add 0.1 to that, it's gonna be 12.1. And it says the word about. So it doesn't have to be exactly. So I'm gonna say this one. Oh, please be right. Please be right. It's not even telling me if I'm right. What happened there? Terrific. Okay, I was right. Well, there you go. There you go for getting started on that one. And let's do one more here. We've done lots of systems of equations. You can do that one for traffic light problems. And we can keep looking at that in class. Let's not do that right now. So the last one, checkpoint for lines of best fit. Which scatter plot could have a line of best fit whose equation is y equals negative 2x plus 108? When I look at this, I see a negative slope. So that means it's got to be going down. And then I see my y-intercept of 108. So I should be able to graph the line with a negative slope, about -2, and it should be having a y-intercept of 108. So this first one, now I'm not choosing that positive. This one is zeros complete across. This could be good. This one, not so good, because even though it is a negative correlation right here, this one would not have a y-intercept up there at 108. So I'm gonna choose this one right here. That one, the best choice. Look at this scatter plot. Which statements are true about the line of best fit for the data in the scatter plot? So can we draw a scatter plot? So what? I can't like draw it. Well, I'm gonna draw it, but I wish that you could draw it. It was either like so. So maybe the scatter plot could be like this. And then the y-intercept would be about 11. And the slope, what would the slope be about? So let's, if you draw a line, make sure you find the slope and the y-intercept. And they're going to be approximate. Okay, so 1, 2, 1, 2, 3, 4, 5. So we know we got a run of 5. 1, 2, 3. So we have a slope of about 3/5 and a y-intercept of 11. So we're looking at 3/5 plus 11. Let's see what I say. Crosses at 0.16. No, it crosses at about 0.11. Has a positive slope, yes. Its slope is about 2, no. Its slope isn't even 1. It has a negative slope, no. The zero slope, no. It crosses at about, oh, well. I guess that if I were to draw a line and I wanted to draw it having a y-intercept of 16, I guess that could work, right? So if I have to choose two, even though my line had 11, I would be comfortable choosing the 16. Not the 25 though. Definitely not the, well, no, just how's it? If I did choose the 16, it doesn't make my line steeper. I'm definitely still not choosing 2. All right. This is what we're gonna go with. Is it terrific? Come on, tell me it's terrific. It's incorrect. What did I miss? A slope of about 2. Well, there you go. So hey, you want wrong? Look at the answer. Okay, so what we should have done was pick 2 points on the line and find the slope that way. And then I would have gotten it correct. I got the other 2, okay? And so we are gonna work on that together. Okay, so this is a great, this is gonna be a great week because you have our new concept of two-way tables, but then we're continuing to practice lines of best fit, reviewing rational and irrational numbers, systems of equations, and you can submit all your traffic light problems, and I will see you in class. And I don't think that was 30 minutes, so that's good. All right.